If you're looking for additional Regents exam info, then jump onto your computer and log on to regentsreviewny.net. It's the official website for the series, and it's loaded with test prep resources that are guaranteed to cure those Regents exam blues. Video clips, test-taking tips, exam schedules, and a host of links to other Regents resources. It's all here. And don't forget, all of the programs in the series will be available for streaming on the site once the television broadcast schedules are complete. So what are you waiting for? Increase your chances for a better score on test day. Regents Review 2.0, the next generation of Regents exam prep. Regents Review 2.0 is made possible by New York State Teacher Centers, providing professional development for teachers by teachers. New York State Teachers Centers, a source for teachers and a promise to students. And by NYSET, representing 600,000 professionals in education and healthcare. And by contributors to your PBS station from viewers like you.
Question number 7. For this cluster, we need to interpret functions that arise in applications in terms of the context. So here again, they give you a big problem to read and to determine the context of, and then try to solve. So here we go. The ocean tides near Carter Beach follow a repeating pattern over time, with the amount of time between each low and high tide remaining relatively constant. On a certain day, low tide occurred at 8:30 a.m. and high tide occurred at 3 o'clock p.m. At high tide, the water level was 12 inches above the average local sea level. At low tide, it was 12 inches below the average local sea level. Assume that high tide and low tide are the maximum and minimum water levels each day, respectively. Write a cosine function of the form f of t equals a cosine bt, where a and b are real numbers, that models the water level f of t in inches above or below the average Carter Beach sea level as a function of the time measured in t hours since 8:30 a.m. It's a lot of reading, it's a lot of interpreting. What I suggest you do is draw yourself a quick picture. They did tell you to make this a cosine function, and we know what cosine looks like. Cosine usually looks something like that. Well, in this case though, when we reread the problem, we're told that low tide happened at 8:30, high tide in the morning, and high tide at 3 o'clock in the afternoon. So low tide came first. So what you need to do then with your cosine function is understand if low tide came first, it's flipped over the x-axis. So a quick sketch of your graph before we try to put it on good graph paper, it would look something like that. Because we started at low tide, not high tide. Okay, always going back to reread. We had low tide at 8:30 a.m. and it was 12 inches below the average local sea level. So, sea level will be your x-axis, and low tide happened at 12 inches below sea level. They said high tide was its maximum, so that's at positive 12 inches. So we have negative 12 inches, we have positive 12 inches. We know that low tide happened at 8:30 in the morning, high tide occurred at 3 p.m. So when we're starting our graph, that's 8:30 in the morning. High tide, the middle of our graph, right here, is at 3:30. Oops, sorry. 3 o'clock p.m. Okay. Go back and remember what you're trying to do here. The first thing we're trying to do is write this function. So we know the a value. We have a height of 12, but it's been flipped over the x-axis to start, so it's a reflection, so we start out negative. So we can start our equation right away as f of t equals negative 12 cosine of something. We need to figure out that b, that frequency value. Well, we know that this tide, between low tide and high tide, was from 8:30 in the morning until 3 o'clock in the afternoon. That is 6.5 hours. 9:30, 10:30, 11:30, 12:30, 1:30, 2:30. 6.5 hours. So a full cycle then will be 13 hours. 6.5 times 2 is 13. So this full cycle of cosine took place over 13 hours. So if you think about it, the end of your graph is at a 13-hour mark. That is the period of your graph. Period of a graph is where your first cycle ends. Well, we have a formula for that. We know that period is 2 pi divided by that b value, that frequency. Our period is 13 hours. So 13 equals 2 pi over b, cross multiply. 13b equals 2 pi, divide by 13, and there is our b value. So finally, the equation that we need, the function that we need is f of t equals negative 12 cosine 2 pi over 13 t. Lots of work to get to that function. And that, I think, is the hardest part of the problem. Again, the number in front, your a value, is your amplitude. The negative is from the reflection. And then your frequency comes from the period being 13 hours. Okay, let's read the second part. The second part of this problem says, on the grid below, graph one cycle of this function. Well, really, we've already done that as a scrap piece of paper. We just need to get it on good graph paper. So we are asked to graph one cycle of the function on the grid below. Well, we've already drawn a really quick sketch of that above, so we just need to make it pretty on our graph paper. Okay, so let's set up our graph paper. Notice it's a clean piece of graph paper, so you set it up how you choose, but you really want it to fit in nicely. Okay, we know that we're going to start at negative 12 and end at negative 12, and our peak of positive 12 is halfway through it. So it looks like we need to count by twos. So we have 2, 4, 6, 8, 10. There's negative 12. And there's our starting point. And at some point we'll get to 2, 4, 6, 8, 10, positive 12 on your y-axis. Okay. We need a complete cycle. So we start at negative 12. You might as well use your whole graph paper. End at negative 12. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 blocks of graph paper wide. So we can go over 7 for the peak at positive 12. You could cut that 7 in half and go 3.5 blocks over for each 0. That's not a bad thing either. And then make your nice smooth cosine curve connecting those points. Okay, you want to label. This low tide was at 8:30 a.m. This high tide was at 3 p.m., which was 6.5 hours. Since this is a time or t axis, you want to make sure you label it in the proper units. And we ended 6.5 hours later, 13 hours in, which would be 9:30 p.m. Okay, so we've drawn our graph, we've labeled it, let's finish the problem. The last part of this problem says, people who fish in Carter Beach know that a certain species of fish is most plentiful when the water level is increasing. Explain whether you would recommend fishing for this species at 7:30 p.m. or 10:30 p.m. using the evidence from the given context. Okay, your evidence is your graph. So our graph is rising, our tide is rising from 8:30 a.m. until 3 p.m. So that would be a good time to fish, but unfortunately those aren't choices. And then your tide is decreasing from 3 p.m. until 9:30 p.m. Our choices are either 7:30 p.m. or 10:30. Well, 7:30 is in here somewhere, so that's no good. That's decreasing. So our answer then will be 10:30, and you have to explain using the context, because the second low tide is at 9:30, so we're increasing at 10:30 or something like that. Use your own words, but again, You just need to communicate very well to whoever's grading your test exactly what you were thinking. We can't grade your head, we can't grade your calculator, so make sure you write really well on your test.
We're rolling.